Như vậy đặt cờ thôi được rồi. Nghe này.
Good afternoon. Nice to see you all back here. You can hear me clearly?
No.
No?
Hello? Hey, much better. Nice to see you all back after lunch. I hope you all had some coffee and you're not sleepy during my presentation. So it's going to be a bit more technical the afternoon. I am going to talk about what we have done at CNX in the last 6 months to prepare for the challenges ahead, how to scale up our business across Cambodia. So I am not sure how many of you are really technical and know what VXLAN kind of means. Anyone hands up that you know what VXLAN is? Sort of? Not too many. Okay. How many of you work in networking? Also not too many. Okay. So then bear with me for the ones that are not really into networking. This is going to be a very technical subject going forward. So VXLAN. How did we come across it and why do we need it? So that was CNX for a very, very long time. We connect customers. So for those of you who don't know, CNX is in the business of interconnecting other businesses. So our job is mainly to connect ISPs to each other, to connect data center to ISPs, and to connect the content provider to ISPs. So we are the pillar in the middle that most traffic in Cambodia goes through. So for us, for the past 10 years, we had a very easy life. We had free POPs, free nodes across Phnom Penh, and that was enough to drive our business. However, as we all know, data is becoming more important. Infrastructure in Cambodia is developing, and we are now looking at a situation where we find there's a lot of data centers coming in Cambodia, there's a lot of providers coming in Cambodia, we're creating more content in Cambodia, so CNX needs to move up. We need to scale. We need to figure out the solution, how we can interconnect services in Cambodia. So if you are somewhat familiar with how a data center works, a data center only works if I can reach someone. If I put my servers in a data center, but I can't get anywhere, then there is no really good point of putting it in a data center. So we have the challenges of coming up with a network that scales possibly to 10, 15, maybe 20 data centers in the future in Cambodia. So our list of things we want, actually quite simple. We need to connect to 10 plus data centers. Spanning tree is not going to work for that, we know that. We need to have each location to be redundant, so we need to have more than one link. We need to have more than one piece of hardware, and we need to build a network that works. Because if data centers rely on us to transport their traffic to customers, it must be a reliable network. So the services that we want to offer connectivity point to point through a common peering infrastructure, and we want to do it at 100 gigabits of speed. So the obvious choice in this is a technology called VXLAN. So VXLAN is around for a couple of years already. It's nothing really new, but there are not many implementations being done, even in larger networks, due to, I think, a learning curve, understanding, and the configuration previously wasn't really that easy, and there is not a lot of good documentation out there, I have to say. So VXLAN is basically a technology that allows you to take layer 2 traffic from one port, bring it over the internet, and putting it out in another port. So it's a bit of a busy graphic, but bear with me. So if you look at what VXLAN achieves, it's a very simple thing for the user. We are going at network A at that site. We are connecting it to a switch port. We then map that VLAN assigned on that port into a virtual network identifier. We take the network frame, the Ethernet frame, we're encapsulating it to UDP. We are building a tunnel to our other end, and we're sending it across that tunnel, and on the other end of that tunnel, we simply take the traffic back out. So what this allows us to do, this technology, is basically have a host somewhere connected to a switch, being able to talk to a host somewhere else in a different data center, in a different country, on a different continent, without host A or B actually being aware of that they are in completely physical separate networks. So from a technology standpoint, that is what we want to achieve. We as CNX want to build a network across all the data centers in Cambodia that allows a customer to connect in one data center and being able to talk to a different customer, a end user or a service or a server in another data center without them being in the need to configure network setup on their own or configure their network services to be routed. So VXLAN as a technology achieves that for us. So there are some other steps involved, and we come to that later. So we are using Huawei at CNX, and I have to say to the Huawei people here, please work on your documentation. It's not as good as it could be. So we had a lot of trouble figuring out how that all works, but in the end, it's actually quite simple once you really understand the component involved. So if you look at the components involved in VXLAN, there's basically two things. One is a bridge domain. So if you see here at the right-hand, it's your right-hand side, a configuration example. Even if you are familiar with Cisco, I think you can easily follow that. Is we're setting up a VLAN, we're setting up an interface, we assign that VLAN to that interface, and then we map that VLAN into what is called a bridge domain. The bridge domain is the identifying piece of software that makes VXLAN work. So VXLAN identifies traffic based on the bridge domain. So all we have to do to make VXLAN work is take the VLAN that only works locally within that switch or router and put it into the bridge domain. And then there's a second step where we define network virtualization endpoints. So network virtualization endpoints are simply VPN devices. As you can see here, I configured two. I simply say network virtualization interface number 1, and I'm adding my VLAN there, and that is the second one, and I'm pointing them on each other. So those two network interfaces can now talk to each other across the internet. So if we go back here, we can see that this VTAP device is setting up VTAP 1, over there VTAP 2. As long as there is IP connectivity between those two, they can talk to each other. So what we're doing in technology-wise, we're taking a network, putting it into a bridge domain, transporting it over to the other side, and taking it back out. Quite straightforward once you understand the situation there. So in the end, we have the ability to ping from A to B without A or B actually being aware of that they are in different locations on different switches in different data centers. So from a technology standpoint, this can really help scale up your network if you need that you basically need to keep layer 2 traffic intact. So there is some more to consider of how to build our network. As I said before, we have some more requirements. And we also need to be able to build infrastructure that is resilient and fast. So I think a lot of you have heard of the concept of spine leaf, which is basically saying spine leaf is a architecture where I make sure that every access device connects to one backbone device. So I can able to build a network infrastructure where I can say that from point A to point B, there is no more than two hubs in between because we know exactly how the network is connected. So spine leaf really helps us building a scalable network. And I think if you think about data center traffic between maybe two data centers, it becomes very important that that traffic is as fast as possible with as low a latency as possible. So in our design infrastructure, we chose to implement a sort of spine leaf, but basically following the same design principles. We also said that we want to have two devices. And here, actually, I have to say, Huawei has a very straightforward, simple configuration. You can just take any of the high-end switches, put two cables in between, and they become a stack. And if you look at the configuration, it's very simple to do. So what it allows us to do is basically we can have two links, one from the first stack member, one from the second stack member. And if one of those links goes down, the stack is still working. If one of the switches goes down, the stack is still working. So we have redundancy at our node at the data center. The way that we use that redundancy is we can basically ask customers to connect with two cables, one to each switch. And then we can configure what is called a multi-chassis link aggregation. This sounds very complicated, but if you look at the configuration, it is actually quite simple. So I have to say, a lot of the concepts that sound complicated on the documentation, and there's a lot of words around it, if you look at the actual configuration, it is often quite simple if you understand once what the technology is doing. So in multi-chassis link aggregation, what we can, for example, say, we have a customer in one data center, and they want to securely connect to another data center. And they require resiliency. They require two routes. We have that implemented. You connect one cable to one switch, the other cable to the other switch. Both our switches connecting to different network endpoints, and we are basically bringing the traffic to the other data center over two different routes. So, how do we configure access to our network? Basically here, nothing much has changed. I think that is all very standard to you. The beauty about running VXLAN inside your network is that your clients, there is no change. You don't need to reconfigure any of your devices connected because the switch from spanning tree or similar setups is done behind the scenes, and your end devices don't actually need to be aware of that. So what we have at CNX, we have a single port access. We basically network A is connecting to network B. Both are connecting, and you see the configuration. It's quite simple, it's quite straightforward. We can also do trunks, where basically one network can access multiple services across our infrastructure. Again, it's a very straightforward, simple configuration. And we already talked about it. We can do MLAR groups, so people are more protected in their network setup. So, putting it all together, the way we build CNX is we have two switches per location, configured as stack. So we have redundancy and resiliency. Each switch has its own uplink. So we are using in the uplink infrastructure layer 2 point-to-point links. We are running OSP at our core, and each VTAP can ping each other VTAP in our network. So customers can connect in one data center on one port to another data center to another port. So, sorry, there's a bit of a busy chart. That is our network, how it looks in the inside. So we have two spine devices. Each of our nodes has two switches. Each of them connects to a different spine device. And inside our network, we run OSPF at layer 3. And then we have a VPN setup, yeah, the network virtualization interface at each of our nodes, and ISPs connecting at different parts to our network can communicate with each other across infrastructure that is basically safe and secure. So, however, that is our goal. We want to build this network across all data centers that are coming up in Cambodia, and those are only the ones we know about right now, and there might be 5 to 10 coming more in the next couple of years. So we need more of technology to make that work, because currently we're having an issue that the configuration would not scale if we keep the configuration that we have right now. So the next part of the puzzle is EVPN. So talking about VXLAN, we have two components. We have the bridge domain that takes the VLAN into the VXLAN, and then we have the network virtualization interface that makes the VPN between each other. Now we need another step to manage the information in our network. So EVPN is basically helping us to manage VXLAN. So don't be scared of the diverting in technology, it sits on top of each other. I have a bridge domain, I have a network virtualization interface, which forms my VXLAN, and then I'm using EVPN on top of that to manage the traffic. So EVPN, managing traffic, non-surprisingly, it works in BGP. So whoever is familiar with BGP and their setup would understand how that works. BGP is managing your routes and is managing your traffic, and basically it serves as the anchor in your network for information. The same thing happens with EVPN, but at layer 2. So, as we already touched on, VXLAN is in need to understand, or basically VXLAN works by each VTAP device forming a VPN to every other VTAP device. So if I have a node in one data center and I want to connect to the node in the other data center, those two devices need to form a tunnel. If I have a device in the third data center, again, those devices need to form a tunnel. So I have a lot of tunnels in my network, because each connectivity between one device to another device builds a tunnel. If I have 10 VLANs that I want to share and I got 10 locations, I need to configure 100 lines of code to actually make them all interconnect. And I think some of you already understand that concept here. You know, BGP helps in that regard, how to make that better. So, what do we actually mean by managing traffic for that? So kind of network VPNs need to know for each package that we have, or for each member that we have. We need to know what is the VLAN, what is the VNI, what is the device IP, what is the MAC address, what is the broadcast domain, and then how does it connect to something else. So basically, if you understand BGP, you understand in the BGP routing table, we have information about each network and how to reach it. Now we are scaling it a bit further and say, okay, we use BGP to store information about each device, not network, but device, and we are putting at the other end which endpoint can be connected to it. So having in BGP previously a table with network and gateway, now we have a table with MAC address and VPN endpoint. Otherwise, same technology. So how to make that work? Actually also not very difficult once we understand what each component needs to do. So we need to enable the function in the switch. We need to set up BGP. we need to add some community attributes to BGP, and we need to configure the network virtualization endpoint. So again, very straightforward configuration once we understand what each component does. So we use, coming back to that, 1 second. We use in this net of the loopback address for the router ID, and we configure peers. The underlying network is OSPF, so that is already taken care of. I don't need to worry about the layer 3 routing. And then I simply have a new command, L2 TVPN family EDPN, that basically enables that function. You're looking at the leaf, the VTAP device, same configuration, not much difference. So all we basically need is turn it on and set up some BGP. Now, there is a small change for our bridge domain. Previously, our bridge domain had no information about BGP. Now we're adding another 4 line of configuration for BGP, but it's not very difficult to do. And then we're also looking at the network virtualization interface. And again here, previously we had to list each VLAN and each endpoint. So you can see here, that list actually is a lot longer on our network, because we have to take each VLAN and mapping it to everybody else. Thereby, moving to EVPN, we simply need to say, this VNI is in BGP. Done. So, VXLAN at CNX allows us to build a complex layer 3 network and then take layer 2 traffic and send it over that network. So previously we struggled with building a complex network because CNX is working at layer 2. We don't have routing. Everything is only layer 2. So VXLAN allows us to extrapolate that network and still keep it layer 2, but build a core that is layer 3, and we can basically use a lot more nodes and a lot more capacity. So we have device and link redundancy in every location, and we have a uniform latency. Because as we said in our previous pictures, sorry to go back and forth, if you look at this network, everything, they have different connectivity needs. If I'm in one data center, I want to have a 10 gig connection to another data center to talk to my servers there. I want to connect to my transit provider. I want to connect to the local peering LAN. So there's a lot of connectivity issues that we have. And using this technology, VXLAN, we are able to simply connect up the customer, assign different VLANs, and put in the right functions. So we can scale our network using multiple 100G links into whatever the future holds in Cambodia for us. Thank you very much.
Thank you so much to Mr. Mike for your presentations. And now, do you have any questions? We can allow to all of you with 2 questions. Any questions? You can ask.
It was very technical, so